Okay, so in this video, we will discuss briefly cryptography. Now, cryptography is the science of encoding and decoding messages. There are several ways of accomplishing this, and in this video, we will consider one method using matrices. Now, a few examples of cryptography. Every time that you are doing online banking or doing some type of transaction online with your credit card, those communications must be encrypted, so that if they are intercepted, people cannot figure out your information, whether it is your banking password, username, or credit card number. So how is cryptography done? Well, there are really two steps. The first step is to convert a regular message into a numerical message. And once you have the numerical message, the idea is to encode a message. The goal is to try to make the message look as random as possible. So you have to use some type of method to transform, to change the original numerical message into one that looks more random. So you need some type of function to accomplish this. And as we've seen before, matrices are functions. So we'll use matrices to shuffle, to make the messages look more random. And we could use a 2 by 2 matrix, a 3 by 3 matrix, or 4 by 4, or any square matrix that is invertible could be considered what's called an encoder matrix, a matrix used to encode your message. So let's start very simply. We'll take first a 2 by 2 matrix as our encoder matrix. And we'll call this matrix E for encoder. And suppose we take the matrix 1, 2, 1, 1. Now in real life you would take a larger matrix, and again, the matrix serves one purpose, to shuffle your numerical code so as to make it look as random as possible. So if someone would intercept your message, they couldn't decrypt it, they couldn't figure out what the original message was. Let's start with a very short message. We'll start with Bob. Just 3 letters. So we'll try and encrypt this message and then decrypt it. Well, the first thing again is we have to convert our message into a numerical message. Well, if you look here, we have a translation. We are going to replace every letter of the alphabet by a number. So A is replaced by 1, B by 2, C by 3, and so forth, up to Z replaced by 26. And we could add additional characters. You could add an exclamation mark for 27, a space for 28. You can add any character of your choice by simply using more and more numbers. And of course we'll keep it simple. We'll only use the first 26 letters of the alphabet. Okay, so the letter B is replaced by 2. The letter O is replaced by 15. And then B again replaced by 2. So that's our numerical message. But it's not encrypted yet. So if someone would intercept this, they could easily figure out that the message was Bob. Well, how do we use our matrix, our encoder matrix, to make this look a little more random? And again, E is called the encoder. Matrix. Well, the idea is we want to multiply our message by this matrix. So this will transform our numerical message in one that looks slightly more random. Well, we have a 2 by 2 matrix in E. If you remember, so E is a 2 by 2 matrix. So the other matrix must also be a 2 by something matrix, so as to have a defined multiplication. M, the number of columns, will depend on the length of the message. So let's start. So it has to be a 2 by M matrix. So every column contains 2 entries. So 215 will be our first column. And then if you notice, there's something missing here. To have our second column, we need 2 numbers, but there's only 1 here. The idea is we'll add 0 whenever we need to complete a column. So here will be 2 again, and there's an entry missing. We'll add 0. So we'll reserve 0 just to complete our columns. And now we have put our numerical message into a matrix. And now we'll shuffle this around, so we'll multiply our matrix by our encoder matrix E. And this will transform our message, which we will now consider at the end our encrypted message. So let's multiply this out. Let's construct the first row. This is a 2 by 2. This is a 2 by 2. The result will be a 2 by 2. So 1 times 2, 2, plus 2 times 15, 30. That's 32. 1 times 2 plus 0, 2. 2 plus 15, 17. 2 plus 0, 2. And now we are going to rewrite this in string form. So the first vector, if you remember, gives you the first components of your code. So this will give us 3217. Second column, second string of our code, 22. And now this is our encoded message. This was the original numerical message. We've used the encoder matrix to transform the original message into one that is slightly more random. And this is the one that we'll send through the communication channel. Now, of course, in real life, you would use a much larger and complicated matrix so as to make the encoded message look even more random. Now, suppose you received this, how would you decode it? Well, you have to undo the transformation E, so you have to use E inverse. So now let's decode our message. Suppose that we are now the receiver. We are aware that this is the encoder matrix, and we want to decode this message. So we must compute E inverse. And this is why whenever you want to encrypt a message, the encoder matrix must be invertible. Otherwise, if it isn't, you will not be able to decrypt encoded messages. We have a 2 by 2 matrix, so the inverse is quite easy to find. 1 over AD minus BC. 1 times 1 is 1, minus 1 times 2 is 2, which is -1, so we get the negative of. We flip these two entries, so nothing happens, and we negate these two. We can distribute our negative sign, so -1, 2, 1, -1. And this is now E inverse. Well, we can now decode the following message. So we go back and put our numerical message that is as a string back into a matrix. The first string of 2 characters, 327 is the first column, 3217. The second string of 2 characters is our second column, 22. And now we want to undo the transformation by E, and so we multiply by E inverse. Now let's see what happens. Once again, the result will be a 2 by 2 matrix. -32, 2 times 17, 34. So 34 minus 32 is 2. -2 plus 4 is 2. 32 minus 17 is 15. 2 minus 2 is 0. And so you see we get the original matrix. And so now if we go back to the message as a string of characters, the first column becomes the first string of 2 characters, so 215. The second column becomes the second string of characters, 20. And now we can convert back into an actual letter message. So we'd go back and say, well, the number 2 gives the letter B. Number 15 gives the letter O. Number 2 we know gives the letter B, and we know that 0 is for an empty symbol. So all we get is the original message, Bob. And that's it. This is how you encrypt and decrypt messages. Let's do one more example with a slightly longer message. What if we want to send a message, Bob is great? Which is obvious, right? Bob is obviously great. And we'll use the same encoder matrix. So as always, the first step to encode a message is to convert the message in a numerical form. We already know that Bob, B-O-B, is 215.2. Then I and S. Let's look up. I is 9. S is 19, so we get 919. G, R. G is 7. R is 18, so 718. E, A, T. Well, E is 5, A is 1, T is 20. So 5, 1, and 20. And that's the first step. We have converted the original message into a numerical message. But now we cannot send this message right away. We have to encode it. We have to make it look more random by transforming it, of course, using the encoder matrix. So 1, 2, 1, 1. And as before, since we have a 2 by 2 matrix, we have to convert our string of characters, or string of numbers, into columns of our matrix. So the first column, 215. Second column, 29. Third column, 19.7. Fourth column, 18.5. And the fifth column, 120. And you see here, everything works out. There is no empty number to complete. In the previous problem, because we had an odd number of characters, we had to complete the last string with a 0 to have a full column. But here there's no need for this. We have 5 full columns to begin with, and so everything is great. Now we multiply. This is again a 2 by 2 matrix. This is a 2 by 5 matrix. 2 equals 2. And the result will of course be a 2 by 5 matrix. Let's construct the first row. 2 plus 30, 32. 2 plus 18, 20. 19 plus 14, 36. Oops, sorry. 19 plus 14, 33. 18 plus 10, 28. 1 plus 40, 41. Second row. This one is simpler. We just do 1 plus 1, so we add the entries in the column. So 2 plus 15, 17. 2 plus 9, 11. 19 plus 7, 26. 18 plus 5, 23. 1 plus 20, 21. And now we will send the following encoded message. Of course, we have to rewrite our columns back into string form. So the first column gives us the first string of 2 numbers, so 32, 17. Second string, 20, 11. Third string, 32, 26. Fourth, 28, 23. And fifth, 41, 21. And this is now the encoded message. So this we would send through the communication channel. And now assume that someone receives it. And again, to be able to decode this message, you would need the knowledge of the encoder matrix, and of course then computing as before its inverse. So let's use the inverse to decode our message. So suppose that we are now the receiver. We receive this encoded message, and then we'll multiply it by the inverse to get back the original message. So we are now decoding the message. So E inverse -1, 2, 1, -1. And now of course we must rewrite the string of encoded numbers into the columns of our matrix. Let's see what we get. First row, -32 plus 34 is 2. Second entry, -20 plus 22 is also 2. -33 plus 52 is 19. -28 plus 46 is 18. And -41 plus 42 is 1. Second row, 32 minus 17, 15. 20 minus 11, 9. 33 minus 26, 7. 28 minus 23 is 5. And 41 minus 21 is 20. Now the message is decoded, but we have to rewrite it as a string of characters. So the first column, 215. Second column, 29. Third column, 19.7. 18.5. And finally, 120. And if you look, this is the original message. 215, 29, 19.7, 18.5, 120. And of course, we would then go back to transforming our numerical code, or our numerical message as it is now decrypted, decoded into our letter message. So we'd simply go back to our translation from the alphabet to the numbers, back from the numbers to the alphabet, and of course we'd get the message, Bob is great. Of course with no spaces, but you can clearly see this will be Bob is great. And that's it. This is how you encode and decode messages using matrices. Now as a last example, let's see what would have happened if instead of using a 2x2 encoder matrix, if we had used instead a 3x3 encoder matrix. We won't go through the calculation, simply how you would set the matrices up. So suppose now that we use the following 3x3 encoder matrix. Let's take 1, -1, 1, 2, 1, 2, 1, 3, -1. Now you can verify this matrix is invertible. And let's see how we would proceed to use this matrix to encode our two messages, Bob and Bob is great. So we had Bob. Let me just look back to the translation from the message to the numerical message. So Bob was just 2, 15, 2. Then we had Bob is great. And this was 2, 15, 2. 2, 9, 19, 7, 18, 5, 1, and 20. Yeah. Okay. So since now E is a 3 by 3 matrix, and we want to use E to transform our numerical messages so that as to encode them, the multiplication must be defined. So we have to put these numbers in a matrix that will be a 3 by something matrix, so as to have a defined multiplication. So let's see what happens with the first message. So we'll use the matrix E to encode it. As always, to make the message appear more random. And now we'll need columns of length 3, right? We need to have a 3 by m matrix. And again, m depends simply on the length of the message. Well, first string of 3 numbers, 2, 15, 2, and that's it. This is the entire message. And this is now our matrix. We would multiply this vector by the matrix, and now we'd have the encoded string of numbers. And I will let you perform these calculations. What about now encoding with, again, this encoded matrix, the message Bob is great? Again, our matrix is 3 by 3, so we need to rewrite our string of numbers into a 3 by m matrix. So we have to pair them up 3 at a time. So the first column, 2, 15, 2. Second column, 9, 19, 7. Third column, 18, 5, 1. Fourth column, and now we only have 20 left over. But as we've agreed, if we ever at the end have a column where we're missing entries, we'll complete the column using quite simply zeros. And there you go. So you would then multiply this matrix by the encoded matrix E. You would get a new matrix of now more random looking numbers, and those would be encoded. You just put them back into a string form, and then you'd send this encoded message. The person that would receive the message, in order to be able to decode it, would have to have knowledge of the encoded matrix, and then they would decode the message, of course using the inverse of this matrix. So this is how you can use matrices to encode and decode messages.